Hi, everyone. First of all, it's great to be here. Thanks for having our paper on the program. It's a joint work of 5 co-authors total. I have great colleagues, 2 of them, and one of them is here. Volodymyr is sitting right there, and he is the co-author that has worked on both of these papers, and he knows a lot about data. So please, it's better to talk to him if you want to know a lot of details about that. The other 2 co-authors, David and Kim. Kim is at the Bank of Canada. David is at the Emory University. They're the ones who hold the keys to the beautiful method that I hope to explain to you today, and I'm here to present. So we'll see how that goes. The views here are not necessarily those of the Bank of Canada. It's ours. Now, the source of both data, ours and the ones from the previous data, is there's some overlap in the source, okay, but there's at least several differences in sort of between the two papers. First of all, our data set is shorter, but it's much wider, and one of the things that we're gonna exploit is the richness of the data set that we have across section in particular. Secondly, we focus. Although we also look at firm-level performance, in particular productivity across and its change across time, we put a lot of weight on explaining how those changes vary across section, in particular how they differ across different industries, across different regions, and across perhaps other dimensions that I'll explain later. Okay. And finally, since at least 60% of co-authors on this paper never worked on Ukrainian data or with Ukraine at all, we look forward to the knowledge that gathered in this group and comments from Monika. Okay. So to give you a little bit of a macroeconomic context, this is just a time series for Ukraine's GDP in billions of 2005 dollars from the independence in 1991. Obviously, there was a sort of a sharp fall right after, when it was the time of breaking trade linkages, establishment of new linkages. It took time to start building democracy, independence, market economy. Today, we have the data that covers the decade after that, and that was the time that during which the economy expanded by quite an unprecedented rate, and it expanded for a while. Okay, so we're going to say that this is in itself is the time in Ukrainian economic history that we could learn a lot about firm productivity in Ukraine. Okay, it's unprecedented because on average productivity during this time, the GDP grew by about 7% per year. Okay, now, one of the things that makes this period interesting is that there's been quite a bit of work out there that says that this growth was not so much due to some fundamental factors, firms improving their productivity, as just benign terms of trade during the time. And indeed, energy prices have been low for most of this period. Firms that use quite a bit of energy, they paid about twice as less as Western firms, okay, for gas. Also, prices for primary commodities, in particular for metals and chemical products, just about doubled during this period, okay? So these are extremely good times for firms that were exporting in these markets during this time. So the question we want to ask is, one is, to what extent this expansion was due to transitory factors like beneficial terms of trade, as opposed to firms investing in their improvement in productivity? And also, we're interested in how much of the windfalls that firms in these energy-intense, low-value-added sectors kind of transferred to the rest of the economy, to firms who are not in these industries, but how much of this windfall was kind of spread out over the economy. Okay, so this is at a high level what we're interested in. Okay, so there's a few bullets on related work. By no means it's complete, and by no means I have any chance of giving due credit to this work. I mentioned just a few papers because they talk about several of the very important factors that affect firm performance in Ukraine, in particular during this period. So there's at least two of the papers by John with co-authors here, they talk about how political turnover or more generally geopolitical factors can be important for performance of firm and their productivity. The firm entry matters. There's a paper by Yuri and Grigorenko that talks about how ownership by oligarchs of firms can be important and not unambiguously bad for firms. In fact, they make a point that oligarchs may have incentives of investing in firm development and sort of reorganizing their firms to be more productive. Finally, so the earlier paper already mentioned that also focuses broadly on how firms performed in Ukraine, and another paper in this session will also talk about that. Okay. So here's what we do. We have a unique data set collected by Volodymyr and Oleksandr. Firm-level data. We're gonna also focus on manufacturing during the 9 years from 2001 to 2009. Okay, and we're gonna examine dynamics of firm-level distributions, not only size, but also different measures of firm productivity. So labor productivity is a classic measure, but we'll also offer a few alternative productivity measures that we hope will be useful for thinking about sort of how firms improved or not in Ukraine during this time. A key piece of our work is this method that is relatively novel, and in particular its application to these types of panel data. It's called Functional Principal Component Analysis, FPCA. Okay, it is something that makes analysis very visual. Hopefully you'll see that today. Analysis of distributions. Distributions are very complex objects, right? Because first of all, they can vary between, say, different industries or different regions, and they can vary in how they move across time, right? And this dynamic can get very complicated. So this is a method that gives due justice to this dynamics of firm-level distributions. What the method does is it takes distribution across firms, say distribution of firm size or firm productivity, okay, and it decomposes this into basically two parts. One part is varying across time, right? It's just something that says picks up the movement across time that drives the dynamic of the whole distribution. Okay, and the other part is a basis function. It's basically a profile that does not vary across time, but it gives you information of sort of which parts of the distribution are the ones that are moving. Okay. The method, the way it works, it's purely non-parametric. It doesn't rely on any model or sort of any assumptions that the model must assume about the data. Okay, and I'll be more specific later. Finally, the method is very good in allowing us to account for heterogeneity in the data, differences across firms that stem from which industry they belong to or where they're situated, or perhaps some other unobserved sources of heterogeneity. So our contributions are basically twofold here. One is it's sort of the method. We're here to advertise the method that we hope to offer to other economists working in this area, suggest that this is a method that could offer some complementary insights into the work that they do. And the second part is when we apply this method to the firm productivity data, it gives us a variety of different new facts. And so far, we have more facts that we can explain. So please join us in trying to figure out what's going on. However, what we can say so far is that, so during this time, it was the time when output grew, productivity have grown as well. So this is sort of overall optimal messages and what we see. And I will offer a few results sort of showing, in general, this message that firm productivity did improve. At the same time, this improvement in productivity was uneven. In particular, it was quite uneven across industries. We do not find as much differences in how productivity changed across regions. And this is something that John just mentioned in their work as well. So I guess we're encouraged that there's some consistency there. And another aspect of our results that we emphasize is that firm turnover, so the changes in composition of firms, in particular from the fact that some new firms enter the sample and they are different from the firms that are present, seems to be important for what we conclude about the level of firm productivity in Ukraine. Okay, and this is something that you emphasize in one of your papers as well. So let me jump to the data. We focus on manufacturing firms. The data is just 9 years of data. Okay, so it's quite short in the time dimension. And that's the reason why this method is quite good, because it does allow us to explain very rich cross-sectional data. The data set comes from compilation of information from forms submitted by firms from their balance sheet statements and financial statements. We have quite a few firms, so we have about 67,000 firms going through our data. On average per year, we have about 30,000 firms, okay? They differ across geographical locations, so oblasts, and across industries. There's 244 four-digit industries, but we kind of aggregate them to 23 two-digit industries. The key variables, similarly to some of the variables that John just explained, are employment, its full-time equivalent. The measure of output is sales after taxes. Capital is the book value of fixed assets. There's also information about wage cost and material cost. I do not have to tell you much about deflators, because most of our measures they don't need for us to deflate these variables. So you will see why. Okay. There's 3 variables across sections, so 3 categorical variables that we will control our data by. The 2 of them are sort of columns and rows here. So rows are industries and columns are regions, and we aggregate regions into 4. Center, north, west, south, and east. And so 23 industries, we add tobacco to food, because tobacco is quite a small industry. So overall, you have 22 rows here. Okay, so what I want to say is that we will report result across industries actually in 4 broader groups, right? So going from top to bottom, between sort of industry 15 to 22, we'll call that light industry. Most of it is sort of concentrated more in the center-north region. Then there is coke, chemical products, mineral products. They kind of a little bit everywhere. After that, it's metallurgy or metal production. So this is 27, 28. So those firms are mostly situated in the east, as you well know. And finally, after that, these are the firms, we'll call them machinery and equipment, right? So these are the firms that have sort of higher value added, let's say, production of primary commodities, okay? So this is 2 out of our 3 categorical variables. And there, so industry and region classification we observe in our data, okay? The third one is something we construct because we thought that dynamics of firm distribution in our data could be dictated by some differences across firms that are not picked up by industry or region. Okay, so we were debating for a while what it could be. So what we decided to do, we decided to define a dummy. And a dummy is one if a firm in any of the 9 years reported a negative accounting profits. We had to construct our proxy for the negative accounting profits, but nevertheless, if it's 1, it means that this firm seemed to have had some profits that is sort of negative or close to negative, okay? And we have about almost half of such firms in our sample, okay? So we hope that this would pick up some differences across firms that are not obvious from sort of what industry they belong to or what region they belong to, okay? What it turned out at the end is that there's a very distinct shift in composition of firms in our data between 1 and 0, okay? So to us, it looked at the end that this mostly is driven by firm turnover. So the new firms, perhaps more productive firms, enter the data set, and they're less likely to report negative accounting profits at any point of time, right? So this is what this dummy eventually will we think, pick up. So if I talk about this dummy today, I'll call it negative accounting profits dummy, but mostly it reflects the change in composition of the firms in our data, okay? What measures of firm productivity we'll look at, or firm performance more generally? First, there's 2 sort of usual variables in this work: employment, so firm size, and labor productivity, so just the ratio of sales to employment. We also want to kind of deepen or expand the types of indicators that tell us something about firm productivity. So that's why we propose 3 other alternative measures of firm productivity. We call them productivity wedges. So this is reminiscent of the literature that does that. So you can think of Shenklinov, there's Cherokee Humagrattan with their business cycle accounting. The idea is to get a proxy of for how efficiently a firm is allocating their production inputs. Okay, if a firm possesses a production technology, you could most of the time thinking of Cobb-Douglas production technology is a convenient way to think about firm technology. Then firm would allocate her production inputs in a certain way, in a certain proportion, and in what proportion can be judged from information about expenditures of these firms for paying for these production inputs. If you just write down a profit function for such a firm with such production function and derive first-order conditions, those conditions would tell you sort of how these factors are allocated. So then if you define that firm is subject to these unobserved taxes or subsidies, right? Unobserved to econometrician, but sort of perceived and observed by the firms, then you can derive the relationship between these production wedges and the information about expenditures on these inputs. So here we have 3 inputs. We have labor, we have capital, we have materials. Okay, so firm spends on those three inputs of production, and firm is perceiving these taxes or wedges that are unobserved to us, but they realize them, right? So, so we can derive these 3 in terms of observed wage cost, value of their output, their expenditure on capital, and expenditure on material cost. The interpretation is the following, okay? The output wedge is basically proportional to the ratio of the wage bill to their sales, and it could be high. If it's high, so it's like high tax on value added. If it's high, it suggests that firm is. If it's high, it suggests that firm is facing some cost of operating a business. Okay, if that output wedge is very, very low, it suggests that firm is getting some kind of hidden transfers or subsidies from the government. Okay? So that's how we're going to interpret it. The second, this capital wedge, if it's high, it suggests that firm has too little capital. So you can think of this as firm has restricted access to financing its capital expenditures. Okay? Alternatively, if it's too low, it suggests that firm has some easy, or perhaps preferential access to credit markets. Perhaps a firm CEO or oligarch knows someone in the government or owner of a bank and has sort of easier way to get funding. Finally, materials wedge, if it's low, it suggests that there's too much of materials, right? So we prefer to think of this as some, indicative of a practice that you can interpret as transfer pricing, right? So somehow a firm can exploit its maybe organizational structure to underreport its sales or overreport its expenditures on material inputs. In any case, we'll think of these wedges. We'll look at distribution of sort of wedges for each firms, and the way to think of it is values of each wedge on the extreme at the tails of the distribution is bad, and values in the middle is good. And since we'll be looking at change in distribution across time, if distribution changes in a way that reduces its tails, increases the mass in the middle, this is a good development from the point of view of this measure of productivity. Okay, so that's how you should think of these wedges and how to interpret the distributions. Okay, this is a very rich data, and it comes with challenges. In particular, there's 3 challenges here. First, as I already mentioned, there's quite a bit of heterogeneity, and we need to have a way to account for it. Second, data is not normal. In our work, in my work, pretty much any model that I use assumes the normal distribution. It's really, really convenient to work with. I also assume the distribution is, so there's stationarity, right? The distribution is not moving across time. This is another convenient assumption made by parametric approaches. Even in John's previous paper, they used a model that is relying on similar assumptions. So data comes with challenges in a sense that a lot of times these assumptions can be quite restrictive and do not hold any data. This is an example. Look at log of employment density by industry region here. So I have 4 graphs for each region. And on each graph, I give a plot of density of log of firm size. And this is for 2005. So what I want you to see in this graph is that these distributions have sort of different tails, right? So they're non-normal. They're quite thick-tailed, okay? And there's differences across industries as well, okay? And you will see later that these distributions actually move around across time quite a bit as well. Okay, so this is just to say that parametric approaches have to make assumptions about these objects, these densities for firm size or other variables that very often just do not hold any data. Our method allows us to circumvent having to make these assumptions because our method is non-parametric. It does not rely on any model. We did a dependent stochastic dominance test, which basically tests the hypothesis that any particular distribution across different years is equal. And in 35 out of 36 cases, this assumption was rejected just to say that these distributions do move across time. Okay? All right, so let me tell you a little bit about this method. Forget about differences across section. Okay, just think about just one variable, so univariate approach, one variable that is distributed with the density f there, and that density moves across time, ft. The method FPCA will decompose it in sort of two parts. One will be time invariant, so it's like a profile basis function that tells us which parts of the distribution will be moving across time, right? But it just tells you kind of what parts of the density to focus on. And the other one is the loading on that profile that will vary across time, right? So the loading will tell you in a particular time how much is the same profile, how much is it weighted relative to other years, okay? So when you multiply one by the other, so theta by g, it will give you the deformation, the difference of the density at time t relative to the average density, okay, f mu. So the object in the red frame is basically the decomposition provided by FPCA. In terms of how we compute these objects, what you do is you construct the empirical covariance operator, and then you look at its eigenvalues, eigenvectors, and nipinutical, they find a way to derive the theta and g from those eigenvalues, eigenvectors. Let me give you a little bit, first, a simple, cooked up illustrative example to show you how FPCA works. Okay? Take two normal distributions, W on the left, W2 and W1, okay? They're not going to be moving, and define an average distribution, which is, think of it as sort of weighted average of the two of these time invariant distributions, and vary the weight across time. So then this weighted average distribution will move across time as well, just like this weight will move. The weight by which these two distributions are weighted will be moving across time like that, like on the right top plot. The deformation, the component, the profile function that is invariant across time is given by this line, right? So this is now moving. It just says the weight will be relocated of the combined distribution will be shifted from this part to this part. And how it will be shifted between any two points of time will be given by this line above, okay? So I'm gonna turn on the movie, which is gonna change the weight from sort of this point to that point. And as that happens, the pole distribution will be changing across time. So as you see, the weight is changing and sort of the resulting distribution is sort of moving, shifting between one time invariant distribution to the other, right? And as you can see, this pool distribution is not normal, and it already, even though this is a very simple cooked up example, the distribution is sort of moving in a sort of interesting way across time, okay? What I want to tell you is that what FPCA does is it takes a distribution that is changing across time like this, and it decomposes this into sort of what shifts them across time and into the profile that gives you information about which parts of the distribution are the ones that are being affected the most, okay? So hopefully this is clear. So now let me tell you about what we do. What we do, we have to account for heterogeneity. So we have to add to this method, extend this method, to be able to discriminate between, say, different regions or different industries. And this is what two of my co-authors did in their beautiful paper published in JASA Journal. They extended this method to be able to account for categorical information. In our case, it's industry, 22 bins, it's regions, 4 bins, and it's the dummy for the negative accounting profit, 2 bins. Overall, we have 176 bins over there. So basically, we can tell apart the densities by each of the 176 bins. Okay, so this is quite a bit of work. So what remains is that now, each of our density, so density over X, where X is one of our measures of firm productivity or the size, but they will also differ by each of these 3 categories. So the profile functions that are invariant also will differ across those categories. Still, the decomposition will spit out just 1 or 2 time-varying loadings that will tell us sort of how, what is the factor that drives a particular distribution across time. So take, for example, log employment and apply FPCA. Basically, on the left-hand side are the densities that we kind of interested in, and this is sort of perhaps imperfect plot of how those densities look for employment. In this case, naturally, it's very it's very close to the 0, which is log of 1 employee. There's extra weight there, but otherwise it's looking like that and changing across time. The first result that comes out is what's called dynamic script plot. It tells you the variance of the distribution explained by each of the component, first, second, third. Okay, so in each case we'll have that the first component explain most of the variance in density. Okay, in this case it's 70% explained by just one component. And the other 2 results are the dynamic, so the time varying component, the dynamic strength components here. You can see that I plot the first 3, right? So the first one, the most dominant one, is looking like that. So it just says that what drives dynamics of distribution of employment across time is pretty much kind of straight line across time. And this is the profile functions, okay, the components. It says that relocation of weights for the size is for the firm sizes between 1 and 7, very small firms, and sort of firms of the size between 7 and about 55. And there's some weights on larger enterprises. This doesn't really tell you how things move for distribution across time. For that, you need to multiply the time varying component by the profile function to get a sort of deformation of the density. So let me get to that. Take log employment first. The way to explain this is the following. First, we plot the deformation, so that's the difference between the density in the very first period, this is in 2001, relative to the average. It says that in 2001, that distribution had a bigger mass for the higher level of employment, and smaller mass at the low values. Okay, so this is how distribution looked in 2001. And it's common across all regions. I'm just giving you sort of the total across regions. We also know how that blue shade was distributed across each of the 4 regions. So that's given by blue line, right? So blue line now differs across regions. So say, well, they're quite similar here, but this says how much, say, east deformation was relative to the sum of all deformation across all regions. Okay? And we're going to compare these. So this is for 2001 at the beginning. Okay? We're going to go to the very end, to 2009. For that, deformation, which is the sum of all across all regions, is given by the red shade, right? So at the end of our sample of 2009, the weight of the density for employment was lower at the higher values of employment and higher at the lower levels of employment. So the movement of the distribution always goes from blue to red. So between 2001 and 2009, in case of employment, the mass went, for all regions, went from being higher at the high values of employment, it went down, and it shifted towards lower parts of the domain for employment, okay? So you can tell that that means that the change in the density of employment shifted towards lower values in this case, okay? And of course, we can break down the deformation by region. Okay. We'll take the same case, employment, same shades, but we're going to break them down by industry, right? So now you can see the differences in how much weight was relocated, so going from blue to red, by each industry. Big difference, for example, in this case, is for light industry. So it says that the relocation of weight was bigger for the light industries relative to the other industries, right? So firms were downsizing during this period, but it seems that in light industries, they were doing it more than in other industries. Let's look at labor productivity. So this is the ratio of sales to employment. Here, the message for all, so if we focus just on the shade, right, going from blue to red, it means that the weight relocated from smaller values of productivity to larger, right? So it means that it seems that the labor productivity density shifted quite steadily from 2001 to 2009. In terms of differences across industries here, the smallest change seemed to have been observed in metallurgy. Okay, so firms in metallurgy, in terms of improving their labor productivity, they lagged relative to other industries. This is my favorite, so let me take extra minute explaining this one, right? So this is output wedge. Remember, for the definition of wedges, we don't like, so the extreme values of output wedge is a bad sign for a firm. Too high value means that firm is facing some kind of cost of operating business. Too low suggests that there are some kind of hidden transfers to these firms. So the question is, how did the distribution of this object, of this output wedge, change across time? And if we see the shift from tails towards the middle, it's probably a good sign for the firms. So let's look at shade. The shade, remember, it goes from blue to red across years, and that's what you see. You see quite a bit of weight going towards the middle, from blue to red, and it goes from the tails, so from blue to red. The tail on the left decreases, the tail of the right looks like it's decreasing as well. So the message using this measure of productivity points to improvement in terms of how firms allocate jointly their factor inputs across this time. In terms of breakdown by region of this particular wedge, there seems to be a suggestion that center north is the one that is contributing the most to improvement in the density of output wedge, whereas south and west are the ones that sort of work in the other way. Okay, so if you want to know, okay, so what's driving this improvement in output wedge, it seems that the leader here is center north, and west and south are sort of not as good, and east is somewhere in the middle. So two more graphs, and then I'll conclude. Capital wedge. Again, let's focus on shade. So for all forms across all regions or all categories, that's given by the shading. The distribution shifts from lower values of the capital wedge towards the higher values of the capital wedge. So that's a movement suggesting that firms Firms on the right end of the capital wedge are the ones that presumably facing harder access to getting financing for their capital. Whereas those on the left extreme are the ones that probably enjoying a preferential access to credit. So the overall movement seems to be from left to right towards higher values of capital wedge, suggesting that perhaps over time some of the productivity improvements were accompanied by also harder access to credit. Here I break it down by this dummy, right? The dummy that distinguishes between firms that at least once reported negative accounting profits and sort of better firms, firms that did not have that. You can see that firms that at least once reported negative profits, they were contributing to the low values of the capital wedge, suggesting that they perhaps were the firms that also sometimes face easier access to credit or perhaps preferential access to credit. Whereas the other firms are the ones that possibly face some cost of getting credit. Finally, materials wedge. If you remember, low values of materials wedge are the ones that suggest the incidence of transfer pricing. In terms of overall movement across all firms, we see a positive development. So the mass of the materials wedge at the low end is decreasing. Right? So if this is how we interpret this wedge, is that it suggests that firms undervalued their sales and overvalued their material inputs, the fraction of those firms has decreased over time. In terms of how that is cut across industries, the best is again light industry. They show the most shift from low values of the material wedge towards high values of material wedge. And again, metallurgy and coke and chemicals and materials are the ones that sort of on the other end of this particular statistic, okay? All right, so to conclude, again, our paper hopefully contributes to this area of research in terms of two dimensions. First, we provide a method that is complementary to a parametric approach to the literature. Parametric approach to the literature has to rely on some assumptions about the data, in particular about distributions in the data, that may not always hold. Our method is immune to that because it's non-parametric. So we suggest that there's some complementarities in terms of what our method can offer to this literature. Also, our method is quite amenable to accounting for heterogeneity in the data. In terms of facts, we have a lot of facts, and some of them I've shown you. Basically, it seems that overall the message was positive in terms of firms' performance and how productive they were. Productivity has improved over time here. However, this improvement was not even across, in particular across industries. We have much less differences across how productivity changed across regions, although you saw that there are some sometimes, but there's much more differences in terms of which industry firms belongs to. We also see quite a bit of evidence that firm turnover, so entry of perhaps more productive firms, may matter in terms of average firm performance. Thank you.
Thank you very much, Oleksiy. So Monika Schnitzer will be the discussant.
Okay. Okay, so perhaps let me start by thanking the organizers very much for inviting me to be here. It's been a unique experience, and I'm very happy to be part of this great conference. And it's in particular a pleasure to be discussing this paper. And let me start right away by quickly going through what you told us already about the legacy of the Ukrainian economy. You saw that out of bad institutions, corruption, lack of domestic competition. All this meant that the industries started out on a bad footing. There was some growth between 2001 and 2007, but as you mentioned, that was due to a large extent to transitory factors such as low energy prices, favorable terms of trade. And the problem that may actually arise from this is that this may have prevented actual development of high value-added industries such as electrical machinery and so on. And there may have been too little reallocation of resources, which then in the end means that perhaps it prevented productivity increases. So what's the contribution of the paper as I see it? I think, well, what it does is definitely it studies the evolution of firm-level distribution of firm size and firm productivity. And it has access to a unique, a very rich data set covering over 67,000 of manufacturing firms. It goes into this analysis by distinguishing different regions, which vary a lot in terms of the industries it holds, so the political background of these regions. We learned yesterday the people think differently in these regions, so that's interesting to consider. And lots of different industries. It's high value added, low value added, but of course, as you mentioned, you distinguished it as much finer. So that's very interesting to look at. The method that you use, the functional principle component analysis, has this big advantage, as you pointed out. It's less dependent on assumptions such as normality and independence, which is a great plus. Personally, my problem with this is that it's also difficult to interpret. So the components that you use here are usually in this method difficult to interpret, and hence it may be actually less suited for policy recommendations. And that's the most important thing that I want to discuss. While I appreciate the results in its depth and breadth, I think it's very difficult to come up with policy recommendations, and this is what I want to focus then on. So in general, the results overall, productivity has improved. That's what you find. It seems like this has been mostly due to downsizing of labor and capital, and perhaps we can discuss this later. This is why I also asked early on, John, what happened in the privatization? Is it really just downsizing, or what else is going on? Then the relative efficiency of capital and labor, you explained, shifted away from capital, which, as you say, suggests increased cost of obtaining finance. And again, that's something I want to come back to, because that would be an important issue for policy recommendations, if that is what is going on. Across regions, you find that there are similar shifts from towards smaller firms, whereas across industries, the experience is actually quite diverse. You find more downsizing in light industries and machinery equipment, not in metallurgy, coke, and the other industries that you mentioned. Okay, having seen that, what were the questions that came to my mind? First of all, I thought it might be interesting to look more into what kind of firms you're actually considering. And so one thing that you mentioned yourself is the role of oligarchs. And what I wonder is, could you distinguish them in your data set, and could you explore this in more detail? Because, as you say, the largest firms in the low value added industries are owned by oligarchs, and it's unclear. That is at least what it's claimed. It's a priori unclear what the impact on productivity is. So Goret, Nishenko, and Kirilenko find some evidence that they did increase productivity. The question is, could you verify this with the method that you're using? And then another paper that you mentioned, and that has been mentioned before, is the paper by Erland Gelbach, who find that after the Orange Revolution, the productivity of firms in regions that were mostly supportive of Yushchenko, there the productivity increased after the elections relative to those in anti-Yushchenko regions. So what I would find interesting is also considering or differentiating between firms depending on where their allies are and who are the owners. I would think that is would be very interesting for policy issues. Okay. Other questions that came up for me, I would have liked to see these results be put into perspective. Now, with your data set, you cannot do that, of course, because you have the data from Ukraine. But whether this productivity increase was a lot or very little, whether Ukraine is actually exploiting its potential, can only be judged by comparing it to other regions and or other countries. And this is what I'm trying to do now. In particular, to find then, in the end, some policy implications. So I was wondering, what are the potential obstacles for productivity growth? What would be potential channels for productivity increase, and what policy recommendations could follow from that? And so I used the two sources that are easy to access, which is the BEEPS data and the Doing Business report. And so in the remainder of the few minutes that I have, I would like to walk you through a number of slides that exploit these data. So the first observation relating the results from the Ukraine to other countries, and now using the BEEPS data set, shows you that indeed labor productivity in Ukraine increased, but not as much as it did in other countries. Now, mind you, this is a much smaller data set, because this is the data from BEEPS for the Ukraine, which is, of course, just a couple of hundred companies. But it does give you some sort of picture, because you can compare this now to, say, Russia, Belarus, Hungary. So Belarus, for instance, is doing much better, it seems, than Ukraine, according to this picture. Now, this is the measure that you're using. It's labor productivity in terms of sales over employment. Now, the next interesting picture actually shows you labor productivity in terms of sales over wages, which is not what you're looking at. And there you see that in Ukraine, the labor productivity actually decreased dramatically. I have no explanation for that. It must be due to the fact that wages increased. And why that is the case and what this is telling us, you will be able to explain. I don't. But that's an interesting observation to be made. Now, my question, of course, was then, what would be potential obstacles for productivity growth? And I mean, we discussed a lot of them yesterday already. So Ukraine is simply not doing well in terms of this Doing Business ranking. It's ranked 96 out of 100 and I don't know what. It's similar to Kyrgyz Republic. So Belarus, again, is doing much better, or if that is a comparison that you would like to consider. And if you ask the companies what factors they find are most problematic for their doing business, this is not doing business, so this is not the BEEPS data. Political instability, of course, in 2013 was perceived as the top obstacle, but right after that comes corruption and access to finance and electricity and workforce skills and all these issues. So corruption, definitely Ukraine is performing poorly here, so you see it's always one of the worst here. So this is now, the higher you are, the better you are. So 100 would be very clean and 0 would be highly corrupt. And Ukraine is here now at 26. And this is something that is perceived by the companies, but what is also perceived by them is the financial obstacles, which in some way you are capturing with your capital wedge, I think. And that, how much that plays a role depends to some extent in which cycle you are. So during the financial crisis, that was particularly important. It seems to be less so nowadays. I'm a bit skeptical about this. It could also reflect that now companies are actually not considering expanding a lot, and hence are not really bothered by financial constraints, because they actually don't see what they would need the finance for. I'm not sure how to interpret that. Inadequately educated workforce, that used to be a huge obstacle. Again, it seems to be less of an issue now. And again, I find this difficult to interpret. So would be interesting to discuss that. Electricity obstacles, again, seem to be less of a problem now. Interesting to discuss. But here, the developments are quite similar in these different regions. And the bureaucratic Yeah, obstacles here again, higher means more days to obtain some, here in this case it's an electrical connection, that is going down, so it seems that is at least somehow an improvement to be seen. So my question then was, what would be potential channels for productivity increase, and could you somehow disentangle that in your data as well? Definitely going back to BEEPs, Ukraine is doing poorly in terms of innovation. In comparison to all the other countries, take Belarus, take Russia, take Poland, take Romania, they are having many more companies, relatively, that are doing innovation. So in Ukraine, there are less than 20% coming up with a new product, less than 10% coming up with new management practices, new production methods, and all that is simply not an issue here. And a similar issue is exports. Usually you would also expect that exports are something that drives productivity increases, because it really forces companies to improve their methods, to come up with good products. And you see that exports have halved in Ukraine, and it simply hasn't picked up, whereas in other countries it has. So fostering exporting seems to be a relevant issue. So what would be my policy recommendations? And these are not new. I apologize for that. It's just the same old problems all the time. But it would be very interesting, I think, if that could be linked more to your paper and to your conclusions. If you somehow could get the foundation from your data to these kind of policy conclusions. So in terms of general business climate, yes, of course, political stability is the overarching goal. Corruption, in reducing corruption, reducing bureaucracy, technology adoption, energy supply. These are the usual suspects, and of course feature here prominently. But there could be some targeted policy as well, like innovation support programs, export promotion program, and then access to finance programs. These would be very targeted in order to foster productivity. And again, my wish would be that this could be coming out from your paper with the help of your data. Okay, thank you.
Okay, thank you, Monika. So we have more than 5 minutes for questions. Please keep it short, and answers as well. So who wants to ask a question? Don't be shy. You want?
Thank you very much. These are all great points. We are aware that this is our challenge, and part of it comes with the territory, because it's a non-parametric method. You put minimal structure in it, so it's much more distance to cover for us to get to actually concrete policy recommendations. Having said that, I think some of the results that we put up there that suggest quite a bit of differences in terms of how firms perform, at least along our performance measures. How much they differ across industries do suggest that perhaps policies that target specific industries or maybe even specific firms could be useful. And we'll see what we can do to make this statement more specific. The labor productivity measure that you showed, that you said sort of went up but then fell. It fell after 2009, from what I could tell in your graph. Our data ends in 2009. So I understand from Volodymyr that there is a chance that we might extend this data, but we'll see about that. But if we do, maybe we'll get back to that. We were hoping to touch base with John's paper on sort of effect of Orange Revolution. That was different on firms situated in different industries, those that supported Yushchenko versus Yanukovych. But we haven't, although it's not necessarily very conclusive, but we haven't seen distinctly that effect in our work so far. But perhaps it deserves even a closer look. So thank you very much.
Questions? Okay, I have 2. So you kind of argued in earlier part of the paper that underreporting of sales profits will be a part of your material, right? So you assign them to the kind of material wage. As far as I know, usually it's done by inflating some, consultancy costs, or, you inflate the consulting to the firm, right? So, and this is part of operating expenses. It's not a part of the material costs. So it's non-tangible. So, I mean, you don't do it very sort of in this particular paper, but just don't, material costs is, it depends. I don't know how it is accounted in Ukraine, but, and second, so you find that in 2000 there is a decrease in the capital wedge. Well, increase, yeah, harder access to capital, right? So it's not surprising, right? So it's right after at the crisis, right? So to the extent, so maybe you want to see what happened right before crisis. So it's sort of almost mechanical, right? So is it a kind of genuine effect, or is it external shock, which sort of country is not, it's a separate issue, but well, this is sort of very reasonable. So at least it says that there's something which you measure, it's correct, right? So, yeah.
Thank you, Vadim. So in terms of overinflating your wage bill, what you spend on consultants, it would not, if we interpret it this way, it would not be in material wage, but it would be in one of the other wages, right? Because all the wages cover sort of how you allocate your inputs jointly or one relative to the other. In your case, it would be something that helps them, that says that their wage bill is higher relative to the capital bill, right? So it would show up in what we call a capital wage. And in terms of, so our data is before the crisis, we only have the first year there, right? So the capital wage suggests that the shift in the distribution across firms was towards firms having harder access to credit right before the crisis.
Okay. So anyone else? Okay. Thank you very much. So let's have a break.